Hello student of grade 11. For math student and applied math student, we're going to do exercise 13.2 derivative. So to find the derivative, using the first principle, the formula is f dash x equal to limit x tends to 0 fx plus h minus fx by h. This derivative f dash x is also written as dy by dx. So when you are deriving fx, we write f dash x for the first derivative, and the formula is this one, and f dash x can be written as dy by dx also. Some of the important formula you have to know for this chapter is when you derive constant term c, we get 0. Suppose we're deriving 10 is constant, so answer will be 0. We're deriving any constant number, it will be 0. Suppose you derive a polynomial xn, we have to write n xn minus 1. For example, if I'm deriving x to the power 5, that means I'll write n means 5, 1 less, power will be 1 less, that means x power 4. It's like 5 x power 5 minus 1, meaning is x power 4. 5 minus 1, n minus 1 means 1 less than this power, so 4. So n comes down, so this is the formula. You have to remember, you have to know this formula. If you derive exponential function, we get the same thing only. D by dx, ex will be e to the power x only. If we derive a to the power x, we get a to the power x log a. If we derive log x, we get 1 by x. For trigonometric function, if we derive sine, the formula will be cos x. If we derive cos x, we get minus sine x. If we derive tan x, we get sec square x. If we derive cot x, I'm just writing here, we get minus cosec square x. If we derive sec x, we get sec x tan x. And if we derive cosec x, we get minus cosec x cot x. So for this grade 11, we just have to know this formula only. These are the important formula. Please note it down before we start the exercise. And if you have to derive using the first principle, this is the formula, f dash x equal this much. We have also some rules, product rules, okay? If you are deriving uv, two functions, suppose you are deriving u and you are deriving v. There are two different functions. Suppose it can be x cosec x. So we are deriving two functions. If you derive two functions, then you have to do product rule will be, first we'll keep the first function as constant, then we'll derive the second function, plus then we'll keep the second function as constant and we derive the first one. So product rule goes for three different functions also, u, v, w, suppose. So when there are three functions, first we'll keep two function constant, u, v constant, and then we'll derive w. Then you can take constant u, w constant, we can derive v. Then v, w constant, we can derive u. So this is a product rule. You can note it down. We have also division rule, or we can say quotient rule also. Division rule or quotient rule. Suppose you are doing u by v. This v will be denominator you have to square, and upside what you have to do is first you'll derive u. V will be constant. U you are doing minus u will be constant, then you'll derive v. So these are the formula you have to know to do this chapter. Okay, please note down all the formula. Let us start question number 1. Find the derivative of x square minus 2 at x equal to 10 using first principle. So we're going to use first principle to derive this. So we'll consider let solution, let fx equal to whatever is given, x square minus 2. X square minus 2. Let us derive using the first principle. Formula f dash x is limit h tends to 0, limit h tends to 0. We can write this one like this also, limit h tends to 0. 1 by h you can write, and in the box fx plus h we can write like this also, no problem. Meaning is same. Instead of by h, I am writing 1 by h separately. You can also do the same thing. I can write 1 by h fx plus h minus fx. You can put the value. X plus h means fx is this one. If I write fx plus h, it will be, in place of x we have to write x plus h whole square minus 2. So what you write, x plus h whole square minus 2 minus fx is x square minus, once again, fx is x square minus 2, and fx plus h means in place of x you'll put x plus h. So x plus h whole square minus 2. Now you can put the value. Break this up, x square plus a square plus b square plus 2ab minus 2 x square plus h square plus 2xh minus 2, remove the bracket, minus x square plus 2. Whichever you can cancel it. X square is cancel, 2 is cancel. You are left with what is common here? H is common, so you are left with h plus 2x. You can cancel this. Now you can put the value. Since downside is no 0, you can put the value of h here. You will get 0 plus 2x, which is equal to 2x. So f dash x, you got 2x. Now you're going to find what will be the value of the derivative at x equal to 10. So since this is f dash x is 2, f dash 10 will be, in place of x you'll put 10, you're getting 20. Similarly, you have to do this one. Fx equal to, we're going to derive x, so fx plus h will be x plus h only. So let us derive it. F dash x, use the formula first principle, limit h tends to 0, 1 by h limit h tends to 0 1 by h, fx plus h is x plus h minus x, cancel, limit h tends to 0, you are getting 1 by h into h cancel, you are getting only 1. So whatever may be the value of x, f dash x is 1, that means f dash 1 also will be 1, f dash 2 also will be 2, f dash 3 also will be. So the derivative at x equal to 1 is 1 only, because it's a constant term, we cannot put the value of x. So this is the answer. Similarly, you have to do question number 3. Using first principle, let fx equal to 99x, so fx plus h will be 99x plus h. You can multiply and write also 99x plus 99h. Now f dash x will be limit h tends to 0 1 by h, fx plus h minus fx is the formula, fx plus h is 99x plus 99h minus fx is 99x. This is cancel, you are left with limit h tends to 0, h cancel, so we're getting only constant, we don't have to put the value of h also. 99 is the answer. So the limit, so the derivative of fx at 100 will be same 99, because we got constant, so only 99 will be the answer. Let's do question number 4. This also you have to derive using the first principle. So fx plus h will be x plus h whole cube minus 27. So if you want to solve here also no problem, afterwards you can put the value. So a plus b whole cube, a cube plus b cube plus 3a square b plus 3ab square. Now use the formula of first principle, f dash x equal to limit h tends to 0 1 by h, fx plus h minus fx. I've used the formula, put the value. What is fx plus h? This is the value I have already solved. X cube plus h cube plus 3x square h plus 3h square minus 27. Minus, what is the value of fx? This is x cube minus 27. Remove the bracket. X cube plus h cube plus 3x square h plus 3xh square, okay, minus 27 minus x cube, minus minus is plus 27, whichever you can cancel it. H tends to 0 1 by h. What is the common here? In this the common is h, so you're left with h square plus 3x square plus 3x h cancel. Now you can put the value of h equal to 0, you'll get 0 square plus 3x square plus 3x into 0, so you're left with 3x square only. This is also 0, this is also 0, you're left with this. This is the answer. Let's do question number 2. Let fx equal to x minus 1, x minus 2. If you multiply, you get x square minus 2x minus x plus 2, that is x square minus 3x plus 2. Let's find fx plus h. So we can put the value here also, no problem. In place of x, we'll put x plus h whole square minus 3 x plus h plus 2. Now solve this. A square plus b square plus 2ab, 2xh minus 3x minus 3h plus 2. Now use the first principle. Derivative of fx, that is f dash x, is limit h tends to 0, 1 by h fx plus h minus fx. Now put the value only. Fx plus h is this one, x square plus h square plus 2xh minus 3x minus 3h plus 2 minus x square minus 3x plus 2. This is fx, this is fx plus h, this is fx. Now remove the bracket. X square plus h square plus 2xh minus 3x minus 3h plus 2 minus x square plus 3x minus 2. 2 minus 2 cancel, 3x and minus 3x cancel, x square is also cancel. You are left with this 2 only, and this. What is the common? H is the common, so you are inside the box we have h plus 2x minus 3. H cancel. Now put the value. You get 0 plus 2x minus 3. Answer is 2x minus 3. So this is the derivative of this one. We can use the product rule and solve also, but since they are asking as part of the question, you have to use first principle. We're using first principle and solving the question. This one also the same. Let fx equal to 1 by x square. So fx plus h will be 1 by x plus h whole square. Now use the formula. Put the value 1 by h. Fx is 1 by x plus h whole square, and fx is 1 by x square. Take the LCM and solve it. LCM is x plus h whole square x square. So when you take both LCM, you have to do cross multiply. This x squared into 1 will be x squared minus this into this, this into this. Let's square it and remove the bracket. If you square it, you'll get a square plus b square plus 2ab, 2xh. Limit h tends to 0, 1 by h. Remove the bracket. X square minus h square minus 2xh x square minus x square cancel. Here common is minus h, so we can write h plus 2x. H plus 2x is left by x plus h. H cancel. Now you can put the value of h. You can write 0 plus 2x so you are getting minus 2x. Here x square, that is minus 2x by x to the power 4. This is the answer. Let's do question number 4. We'll consider let, this also first principle only, let fx equal to x plus 1 by x minus 1, and fx plus h will be now use the formula. F dash x will be 1 by h fx plus h minus fx. One by h, fx plus h is this one, x plus h plus 1 by x plus h minus 1, minus fx is x plus 1 by x minus 1. Take the LCM, x minus 1, cross multiply, x plus h plus 1, x minus 1, x plus h minus 1. No space I'll do here. Limit h tends to 0, 1 by h, multiply x square minus x, hx minus h, then x minus 1. Multiply this also, x square plus xh minus x plus x, 1 into h is h minus 1. Now set keep as it is. Remove the bracket, x square minus x plus hx minus h plus x minus 1 minus x square minus xh plus x plus x minus x we can cancel here only. So we don't have to write this, we can write x square plus hx minus h minus 1 minus x square minus plus is minus xh minus h plus 1. X plus h minus 1, x minus 1. Whatever you can cancel it, x square. One minus 1 also cancel. Hx also cancel. You are getting minus 2h by so this is cancel. You can put the value of h now. Minus 2 by x plus 0 minus 1, x minus 1. So you are getting minus 2 by, this is x minus 1 only, x minus 1. So you are getting minus 2 by x minus 1 whole square. This is your final answer. You can pause the video and write the solution. The other question we will do in the next video. Thank you.